same study in 2000 compared the impact of soda versus jelly beans. They had people add 28 extra spoonfuls of sugar to their daily diet in the form of jelly beans or soda pop. Then they measured how many calories they ate over the rest of the day to see if their bodies would compensate for all that extra sugar. This is how many calories the jelly beans group was eating before the study started. But when eating handfuls of jelly beans, their bodies registered all those extra calories, so they ended up eating less of everything else throughout the day. So even adding the jelly bean calories, they were eating pretty much the same number of calories before and after adding jelly beans to their diet. But in the soda group, this is how much they started eating. And despite all the added calories from the cans of soda they were drinking every day, they kept eating about the same amount. So with the soda calories added in, no wonder they gained weight after a month of drinking soda. Their bodies didn't seem to recognize the extra calories when they were in liquid form, so it didn't compensate for them by reducing their appetite so they'd eat less the rest of the day. This lack of regulation may be used to advantage, the researchers suggest, if you want to get fat. But what if you don't? If we drink a smoothie for breakfast instead of a solid meal, will our body think we skipped breakfast and make us so ravenous at lunch we eat more than we normally would and end up gaining weight? OK, well, first, is this solid versus liquid calorie effect real? Soda and jelly beans don't just differ by physical form, they have different ingredients. That's a problem with a lot of these kinds of studies. They use dissimilar foods, like this study comparing liquid to solid breakfast. They either got fruit juices and skim milk for breakfast, or oatmeal with blueberries and apples in it. And lo and behold, study subjects were less hungry after the oatmeal. Duh. That may not be a solid versus liquid effect. Those are completely different foods. To test for a solid versus liquid effect, you'd have to use the exact same food in just two different forms. Even this study was flawed. It purported to show that eating apples before a meal is so good at filling you up, you eat fewer calories overall, but that pureed apples weren't as effective. But they didn't just blend the apples, they baked them for 45 minutes first, which may change how the body handles it. So I'd seen all these studies, but was just not convinced there was a solid versus liquid effect, and then this study was published. A solid fruit salad, raw apples, apricots, and bananas, with 3 cups of water to drink, or take 2 cups of that water, add it to the fruit, make a fruit smoothie, and then just drink that 3rd cup of water. So the identical meal, one in solid form, one in smoothie form. What happened? People felt significantly less full after the smoothie. Same amount of foods, same amount of fiber, but in smoothie form it just didn't fill people up as much as eating fruit au naturel. Originally, we thought it was the lack of chewing. The act of chewing itself may be a satiety signal, an I've eaten enough signal. And indeed, comparing 35 chews per mouthful to 10 chews per mouthful, if you ask people to eat pasta until they're comfortably full, those forced to chew 35 times per bite ended up eating about 1/3 of a cup less pasta. So there we have it. We have the proof of solid versus liquid effect, we have the mechanism here, and as so often happens in science, just when we have everything neatly wrapped up in a bow, a paradox arises. In this case, the great soup paradox. Soup, pureed blended soup, essentially a hot green smoothie of blended vegetables, is more satiating than the same veggies in solid form. The same meal in liquid form was more filling than in solid form. So it can't be the chewing. In fact, there doesn't appear to be a solid versus liquid effect at all, since cold smoothies appear to be less filling, but hot smoothies appear to be more filling. So filling that when people have soup as a first course, they eat so much less of the main course that even when you add in the calories of the soup, they eat fewer calories overall. So how can we explain this paradox? Maybe pureed fruit is less filling than solid, but pureed vegetables are more filling? I guess you could try making apple soup or something, but who's going to do that? Purdue University. To prepare apple soup, they mixed about a cup of apple juice with 2 cups of apple sauce, liquefied in a blender, and heated it up. If you have people eat 3 actual apples instead, they start out pretty hungry, but within 15 minutes of apple eating, they were hardly hungry at all. Drinking 3 cups of apple juice didn't cut hunger much at all, but what about the soup, which was pretty much just hot apple juice with applesauce mixed in? It cut hunger almost as much as the whole apples, even more than an hour later, and even beat out whole apples for decreasing overall calorie intake for the day. What's so special about soup? What does eating soup have in common with prolonged chewing that differentiates them from smoothie drinking? Time. It took about twice as long to chew that many times, and think how long it takes to eat a bowl of soup compared to just drinking a smoothie. Eating slower reduces calorie intake. Or maybe we just imagine the soup to be filling, and it's like a placebo effect. Feelings like hunger and fullness are subjective. People tend to report hunger more in accordance with how many calories they think something has, rather than the actual caloric content. If you study people with no short-term memory, like in that movie Memento, where they don't remember what happened more than a minute ago, they can overdose on food because they forgot they just ate, which shows what poor judges we are of our own hunger. And it's not just subjective effects. In this famous study, Mind Over Milkshakes, if you offer people 2 milkshakes, one described as indulgent, decadence you deserve, the other sensible, guilt-free satisfaction, people have different hormonal responses to them, even though they were being fooled and given the exact same milkshake. And finally, maybe it was just that the soup was hot, and warmer foods may be more satiating. So how do we figure out if the solution to the soup mystery was time, thought, or temperature? If only this study had a third group. They had a solid eating group and a liquid drinking group. If only they had a liquid eating group too. And they did. They also offered the fruit smoothie in a bowl cold to be eaten with a spoon, very unsoup-like. So if it was thought or temperature, the fullness rating would be down by the liquid drinking, the smoothie. But if it was just the slowed eating rate that made soup as filling as solid food, then the number would be up closer to the solid eating group, and it was exactly as high. Meaning the only real reason smoothies aren't as filling is because we gulp them down. But if we sip them slowly over time, they can be just as filling as if we ate the fruits and veggies solid. Wow, this study thought of everything. You don't know the half of it. They also wanted to see if it would work with high-fat smoothies, so what, almond butter or walnuts? No, the LF drink was a liquefied fat smoothie of steamed pork belly. I guess sometimes smoothies can suppress your appetite.